How are force, distance, and work related graphically? This is the question students explore in Investigation 9A, Work in the Force versus Distance Graph. This investigation is broken into 3 parts, where students first explore the work done to lift a mass, then explore the work done to stretch a spring, and finally apply their new knowledge to build a system that matches the work done in either previous part. For part 1 of the investigation, level the track and then mount the super pulley to the end of the track. Attach the hook to the cart's force sensor and then tie a piece of thread about 1 meter long from the hook on the cart over the pulley to the mass hanger with 12 washers on it. Adjust the height of the pulley so the thread is also level. Open the 9A experiment file and connect the cart using Bluetooth. Once the cart's connected, zero the cart's force sensor while nothing is touching the hook. Reattach the thread and then slide the cart toward the pulley until the mass hanger is just above the floor. Start recording data and then slowly and steadily lift the mass a distance of 30 centimeters and stop. In your software, use the statistics tool to find the average force on the graph. And then use the coordinates tool to find the actual distance the mass was lifted. Multiply those values to determine the work done to lift the mass. Next, use the statistics tool to determine the area under the force versus distance curves. After you've done that, compare that value to your calculated value for work. The values should be equal or nearly equal, implying that the area under the force versus distance curve is equal to the work done to lift the mass. For part 2 of the investigation, remove the thread and replace the super pulley with an end stop. Attach the spring between the hook on the cart and the top of the end stop. Again, zero the cart's force sensor while nothing is touching the hook. With the spring completely unstretched, start recording data and then slowly and steadily stretch the spring a distance of 30 centimeters and stop recording data. In this case, force was not constant, so the product of force and distance cannot be used to calculate the work done to stretch the spring. Students must use the area under the force versus distance curve to determine the work done to stretch the spring. In part 3, students can choose one of 2 match challenges. They can either modify the setup and procedure used in part 1 to match the amount of work done in part 2, or modify the setup and procedure used in part 2 to match the amount of work done in part 1. For example, in part 2, the amount of work done was 0.81 joules. Students can modify the part 1 setup by changing the amount of hanging mass to 275 grams. Now the force sensor will apply 2.7 newtons for 30 centimeters, which is the equivalent of 0.81 joules of work.